Hello, my name is Amin, and today I will be presenting on how to 3D model and 3D print. So, before we get into the presentation, in case you don't know me, I am Amin Naqvi. I was born in Edmonton, though I moved to Calgary at such a young age. I was essentially raised there. And my family is from Pakistan and India, and I'm currently in my second year of mechanical engineering, working in the engineering group of this lab under the supervision of Scott. And in my free time, I enjoy reading and photography and bird watching and paleontology, as you'll see very soon, and gardening. These plants in the bottom right corner are all the plants that I've gathered this year in my dorm. And now, on to modeling. So, if you want to design a part, you need to understand why you're making that part, what's its purpose, and how it fits into other parts in the model, and as well as how precise it needs to be. So, in this working in this lab, I have generally been 3D modeling for the automatic pipetting robot project. For that, I've created this standard tray that has a bunch of rectangular holes, all of the same size, and I needed to make these parts that are able to hold all these different things that this tray will need and fit them into these standard rectangular holes. So I've created parts that are able to hold vials of different sizes and uh, pipette tip boxes and 96 well plates. And from that, I was able to learn a lot more about, like, solidify my knowledge about 3D modeling and things like tolerances and other things you need to know. So for this project, I will be taking inspiration from the Elasmosaurus that I walk by in CSIS every day. And by the way, it's not a dinosaur; it is simply a prehistoric reptile. And I will also be using this piece of acrylic, just a scrap piece that I found in the lab. So, first thing you need to do is choose which program you will be using to 3D model. Fusion 360 is one of the main programs that is used for 3D modeling in engineering parts, and it's a good program. It has everything you need to be able to 3D model well. And SolidWorks is very similar to Fusion 360, though I would say it is better in its capabilities as it is able to do a lot more simulating, though it is also a lot harder to access for free, and its license is very expensive because it's made for companies. Like, it doesn't have an educational license. Even I don't have a license for it because I have not yet taken the course that teaches it. And there's also SketchUp, which is generally used and was made for architecture, but it is also a really simple program to use. I was taught this as my first 3D modeling program by my teacher in grade one for some reason, so it's a simple program to pick up. And Blender and other programs like that are fill a fairly different niche as they are better for organic modeling and animating. And Fusion 360 is the program that we will be using today because it is what we use in the lab, and it's also generally a really effective 3D modeling program, and it has both a free version and a free educational version. And so let's dive right into the modeling. So first thing you need to do is take measurements of the parts that this object will be interacting with to make sure it's able to actually fit in properly. And I will be making a model of this piece of acrylic in the program so I can better visualize how this object will be fitting together. And if it's a more complex design, you might also just want to make, like, just on paper a drawing of or just general plan of how you're going to be modeling this part. But this thing is fairly simple, so I will forego the step. And now on to creating sketches. So programs like Fusion 360 and SolidWorks generally work by having you draw a two-dimensional thing and then extruding or some other way turning it into 3 dimensions. So to do this, we start by making this rectangle, and then we add a circle into the middle, which will become the hole. And then we extrude this shape that we've made to be the thickness of the piece of acrylic. Now that we've made that, I decided that for this model it would be best to have this piece of acrylic rotated a little. So I've simply used the move function and rotated the piece. And lots of these functions in Fusion 360 have the keyboard shortcuts to make the modeling faster and easier, and I've put them up in brackets in case anyone wants to see what they are. And now I will be inserting the actual model of the Elasmosaurus. So I will not go into too many details of how I got this model because it can sometimes be very painful and difficult to get 3D models from the internet depending on what you're looking for. But essentially I got this STL file, which is a 3D model file, and I will simply be using the insert mesh function to insert it into the program. Now that I've done that, I will be resizing it and moving it around because right now it is so big you can't even see the piece of acrylic. And so I can also, there's a scale mesh function that allows me to scale the model, and I've finally resized it so that its head is able to fit through the hole in the acrylic. And now I will be turning these into separate components, meaning just separate parts that do not interact with each other, just so that I don't accidentally have them merge together or something that I don't want to happen. And so I can keep the parts separate and identifiable. And then I will be making another part that will be holding the piece of acrylic with to connect it to the rest of the model. And so for that, I made the sketch that is just a block, and I'm projecting the piece of acrylic from this angle onto there so that I have a side view of it so I can carve it out of the block. And then I will be using the offset tool to make a slightly larger hole in the piece of acrylic, because though in a perfect world a piece the same size as the hole it's supposed to get into may work, in real life because of imperfections you need to make the hole slightly larger so that the piece is actually able to slide in with not too much friction and it not like too large of a piece or something like that. And so once I've done that, I will simply extrude it again. It's very simple to just extrude it to the other end of the acrylic piece so that it's just the right length, though this is a scrap piece that I'm using in real life, so it's not actually going to be this perfect. And then I will be using the fillet tool, which essentially just rounds the edges to however much of a degree you want, and this will hopefully make it easier for the piece of acrylic to slide in. And then I'm using the chamfer tool on some of the other edges. This is similar to the fillet tool, except it makes a angled edge instead of a curved edge. So I'm using this just to cut out extra material and give this thing more shape than just a rectangular piece. And now I'm just going to be test printing a small section of this just to make sure it's actually able to hold the acrylic. I'll get into more details of 3D printing in the latter half of this presentation, but I've essentially just test printed it and seen if it can fit into the acrylic, which yes it can. It's a little loose, but this works for our purposes. If I found it too loose or too tight, then I would simply change the offset amount and reprint it to see if it fits better. Now I'll be working on making a lot more of the base. So this is, I can make it whatever shape I want. So I'm using the spline tool, which essentially connects all the points that you place on here using a curve. And so I'm using that to make this egg shape. And I will be using the dimensions tool to just specify the dimensions of it, which is especially useful in engineering parts because it lets you be very exact with what you need to do. And once I've done that, you can see everything is labeled and now the egg shape is symmetrical. I will now be using the sweep tool. So what I have done here is I have made more sketches of circles, and I simply use the sweep tool to bring these circles along the line that I had made and essentially turns it into a pipe shape. that follows the line. And so now that I've done that, I have decided to add on this little rectangular prism just so that the supports are easier to attach to this piece. And now, so I move from editing this piece of the acrylic holder to editing the Elasmosaurus piece. So I've made more sketches just on that face of circles that I will then extrude up into the Elasmosaurus. And I have used a bit of an angle in the extrude function, which is a cool thing you can do, and this gives it just a nicer shape than flat pillars. And now that I've done that, I have switched to editing the whole model, and I've made these sketches of holes for the screws. And I just simply extrude that into a shape that is slightly larger than the screw so that the screw can slide in and out nicely, because I will not be screwing directly into the plastic, though you can if you want to. It is better to use threaded inserts, which I will be describing a little later. But they are essentially like nuts that you melt into the plastic to better hold the screws. So I've made these little holes for the threaded inserts to fit in. And now that I'm done that, we will have to deal with the difference between solid bodies and meshes. In 3D modeling, these are the two ways that programs deal with the 3D components. Solid bodies are better for simpler engineered parts that use shapes like circles and all that, as they simply they take less computing power, and while meshes are better for more organic things because they use a mesh of triangles to more accurately create the shape of that object. And these are unfortunately very different. You can I want to turn this into one singular body so I can 3D print it. So because it is much easier to convert a solid body into a mesh than the other way around, I will be converting these solid pillars into meshes. So for that, I simply use the tessellate function, which converts the body into a mesh, as it says. And then there are some options, though I don't really need to worry about those. And once they've been turned into a mesh, I can use the combine function to just combine this whole thing together. And it's pretty simple, though it did give an error, but generally errors with meshes and all that are really simple to fix. I literally just clicked on the error and just press OK when it says that's going to fix it. So if you get those, don't worry. And now that I've gotten this far and I've essentially just made everything properly, I am going to export it to the slicer for 3D printing. So to export it, so the slicer is a program that slices the model up and turns it into code for the 3D printer to be able to print. So Fusion 360 is really nice in that it just has a button that you can press to export it to the slicer of your choosing, and because different 3D printers use different slicers. And I just select this program and send it to Prusa Slicer because we will be using Prusa printers. Now that it's in here, I can adjust a whole number of settings, though generally you don't really need to touch these, and you don't really want to unless you know what they do. But the only one we will be changing is the type of support. Organic supports are best for models like this, organic shaped models. They use these little tree shapes, and they are for some reason just better at holding the model and easier to take off. Whereas there are also grid supports and snug supports that you use in these in more like engineering type parts that don't have as much of an organic shape to them, as they just hold the model better and work better for these parts. And once we've done that, we will simply export it to an SD card. And then now we get on to the part about actually printing. We take the SD card, we just put it in the printer, and the printer we choose the file, and the printer starts printing the file. It's pretty simple. And as for the type of plastic we are using, generally the plastics you will find, especially in places like the Alco Engineering Garage. Uh, and just plastics that everyone uses for 3D printing are usually PLA or PETG. PLA is the main one. It is really nice, not expensive, and it's good for especially for prototyping parts. PETG is similar, though it is stronger and has a higher melting point. So if you want a stronger piece, for example, you would generally use PETG. So we are going ahead to print this in PLA. There are also more accurate resin printers that you can use if you want something really accurate, though they are also a lot more expensive. These are what people use for printing things like Invisalign. And so we have gone ahead and printed. And now we will be using these tools to just take these prints off the bed and then remove all the supports. Generally, removing supports is pretty simple, though these blue plier shaped tools are really good for just snapping supports off that you find difficult to remove. And now onto the final assembly. Here we will be actually putting in the threaded inserts that I mentioned earlier. So for this, I just held these golden pieces with tweezers over like on the plastic, and then used the soldering iron to melt them into the plastic, and then I just simply screw everything together with the acrylic piece in between, and now we have our final result. And so I hope this presentation was useful. I hope this inspires those of you who don't know much about 3D printing to go out and try 3D printing. And thank you for your time.